Hey, friends. It's Mr. Rogers here, and I wanted to go through these hormones with you, and so we're all on the same spot. So we're gonna do this probably in two parts, probably a little bit on Monday and a little bit on Tuesday. And so I'll tell you somewhere in the middle of this to take a pause, and we'll come back and do the rest. So each one of these glands is a major gland inside your body. Hopefully, none of these names kind of stick out to you as things you've never heard of before. Maybe a couple of them, but they all should be something you've heard of before. Your hypothalamus and your pituitary gland are in your brain. They're kind of, if you go backwards from your nose, they're like right in the middle of your skull. Obviously, they play a huge role. So the hypothalamus controls the pituitary gland. The pituitary gland's one of the main jobs is for it to control everything else that is a gland inside your body. And so most of your glands don't actually have a, I guess, quote unquote, a thinking capacity. It's your brain that tells it to do something, then it does something. So let's go through some of these. So oxytocin is a peptide. Like I said before, you only have to know the gland, hormone, or representative actions. But so it's a protein-based hormone, and its main goal is to make the contraction of the uterus and the mammary glands when breast milk needs to be made. And both of those obviously are going to be positive feedback systems. They are not something that needs to be happening all the time in a normal, especially for these two, obviously for female. Oxytocin also is a big drug in your brain. I shouldn't say drug, but it's a big hormone in your brain that causes things like affection and love. And so when you feel love, you're actually feeling a surge of oxytocin in your brain. But when oxytocin gets sent out of your brain, it goes to these two places and does these two things. Those kind of cells have the receptors. They have the spot for these guys to come in and actually affect these changes to those kind of cells. So that's another big thing. That's why I like starting with oxytocin, is understand a lot of these hormones play a big role in your brain, but once they get sent out of your brain, they could do something else. So oxytocin's a big one. So when you feel love for something or someone, you're feeling oxytocin in your brain. Some chemicals can duplicate oxytocin that are illicit drugs and other things. There's some chemicals that are precursors or can partially fit into the oxytocin receptors in your brain, by the way. One of the most famous ones is chocolate. And so girls, especially, chocolate can do a couple different things. One, it can help bond to some of the oxytocin receptors along your body. A lot of females like chocolate during their cycling, their menstrual cycle, and a lot of that has to do with this stimulating the contraction of the uterus. It's just part of the process. So kind of interesting. If you have more questions about that, you can ask me. Antidiuretic hormone. So this promotes water retention. So basically, if you have this hormone go through your body, you're trying to hold water. If you don't have it going through your body, you're getting rid of water. And that's all about the water and salt balance inside your body. And that's what this is. Pituitary gland is trying to balance, is this. Okay, it's trying to balance the water and salt balance by holding back water. So the more antidiuretic hormone, the more water you'll hold. You might have heard somebody being on diuretics before. That's a drug that gets rid of water. Gets rid of your water if you have too much inflammation or other things, and it makes you pee all the time. So antidiuretic holds water. Growth hormone, it stimulates growth. You're always going to have growth hormone, even if you're not growing. Obviously, there's different times in your life where you're going to produce different kinds of growth hormone that produce different things, like height gain and stuff like that. But for the most part, you're always going to have growth hormone because it helps promote the growth of cells in different areas. And it's not just about getting taller. Yeah. Prolactin is used for milk production. So that is something that's going to be positive feedback. Once it gets going, it's going to keep going and cycling more and more and more. And then once it stops, it ends. Interesting thing about prolactin is it's obviously all of these hormones, by the way, are used in other living things, and they're not just unique to humans. Prolactin, for example, is not just unique to humans. It's almost in all vertebrates, and things like fish and whatnot. It's used for water salt balance and buoyancy. In mammals, it's used for milk production. In other organisms, it can be used for lipid production, where to store lipids, which makes sense because milk, especially human milk, has a lot of lipids in it. And so same kind of idea. So just understand that all these hormones are used in other living things as well. FSH, LH, they're both, and these two, they're both designed to affect the reproductive systems of humans. FSH is going to stimulate the production of an egg every single month in a female, and sperm in males all the time. And the LH is going to be the release of the egg and also the release of the sperm into the vas deferens and other areas of the testes waiting for release. So both these are very important, mostly for the females. If you have a general idea of FSH and LH, you can kind of see where you're at in your cycle. And this is also the two that your body is actually giving off at different rates during the whole month, and also what pregnancy tests are looking for is FSH and LH. TSH is a thyroid stimulating hormone. It's going to make your thyroid actually either increase or decrease your metabolism. Your thyroid also has a role in this as we get closer to it, but this kind of gives an overall command to what's going on in your thyroid. So your thyroid's in your neck, but your brain's kind of controlling it. Your adrenocorticotropic hormone, or ACTH, this is going to be commanding your adrenal cortex. So this is going to make you have things like stress and that feeling of worry inside of your stomach and also in your brain. So cortisol is made from your adrenal glands, and cortisol is the stress hormone, and this kind of helps control it. So if your brain feels stressed, it sends a signal down for your adrenal glands to start making cortisol, and cortisol kind of affects your whole body in a different way. For each cell, it's a little bit different, but some of us don't do well with stress. Some of us are okay with it or have means to get around it, but it all stems from this guy right here. So when you feel stressed, it's this hormone. T3, I'm going to try. It's kind of funny. I'm going to try when it's thyroid. But anyways, it is going to be used for maintaining your metabolic processes. So this is the one that is going to determine how fast your metabolism is going, fast, slow. It ramps up during the day. That's one of the reasons why you can get super hungry at certain times, because your metabolism's like, all right, well, we always eat at 6 p.m. and at 6 p.m. and you're not eating, and I'm ready for you to eat, and everything like that. Okay. Thyroxine is the same idea. T4, it's going to be doing the same idea, but T3 is a little bit more common. Calcitonin is going to be doing with how much calcium is in your blood. This has to do with your acidity in your blood, trying to keep it basic or acidic in different spots. Also, calcitonin is going to help with your stomach, produce acid, and also control those acids. Then we have the parathyroid glands, which is behind the thyroid gland. Okay, you can kind of see that there's little spots here for them. On this guy, the little butterfly, it's a butterfly in your neck, and this raises your blood calcium levels. So this one has the opposite effect of calcitonin. I think that's a good place to stop. So if you want to stop and then come back tomorrow, that's good. So I'll give it a couple seconds and I'll keep going, but that's a good place to stop. And remember, we have to learn all these by Wednesday: their gland, their hormone, and their representative actions. All right, so keep going here. So we have a couple more here. We have the pancreas. These are probably the most famous. Well, the top one's probably the most famous one. The bottom one never gets enough recognition. But pancreas is insulin and glucagon. So your insulin is going to lower your blood sugar level. So if your blood sugar level is too high, you're going to produce insulin. If you produce too much insulin, your body gets overused to it and it doesn't work as well. And then you can get things like diabetes, or your insulin just doesn't work. It doesn't lower your blood sugar. And so this is going to lower your blood sugar by taking glucose and moving it to your kidneys, livers, and muscles, and taking glucose and turning it into glucagon, or sorry, not glucagon, glycogen. Sorry, too many words here. Glycogen, which was something we talked about, macromolecules to store glucose in your body. So insulin's going to turn glucose into glycogen. If I don't have enough glucose in my body, I want to take that glycogen and turn it into glucose again. So glucagon will turn on. Like I said, insulin is a lot more famous now. This is the one that's going to be more dealt with like issues in diabetes than glucagon will, but they're both very important to the human body. The adrenal glands. So we have epinephrine and norepinephrine. Both these, if you wanted to just think of them in a different way, these are both the precursors to adrenaline, and so they're basically seen as adrenaline instead of just epinephrine, norepinephrine. And you kind of heard of epinephrine before, because if you take away the back letters, epinephrine is what's in an EpiPen. That's why it's called an EpiPen, because EPI right there. It's just basically an adrenaline shot to open up your blood vessels. So this is what it kind of does. You kind of give a general sense, but you guys have all felt an adrenaline rush before. That's where you're getting this from. Okay. Adrenal cortex, we have the glucocorticoids and the mineralocorticoids. They're going to basically control, again, they help control the blood sugar level. This is one of the reasons why you never really hear about glucagon, because if your body's not doing a good job with glucagon, you're going to probably replace it with more glucocorticoids, and you have a backup for it, basically. It's not going to completely back it up, but it's better than insulin. There's nothing else besides insulin that controls your or lowers your blood glucose levels. Evolutionary wise, why there's only one that lowers it and two that raises it is before our time, there was never really a situation in human life where they're going to have too much sugar. There will be a lot of situations where they wouldn't have enough sugar stored. And so this is a big part of this, is now we have too much sugar and we don't have many things to lower blood sugar. Next, we have androgens and estrogens. Androgens are going to come from the testes. Those are going to be testosterone. They're going to give, obviously, production of sperm, but they're also going to give secondary male characteristics, things like beards, deeper voice, things like that. Estrogen is going to be the female version of this. It's going to give secondary sex characteristics. It's also every single month going to spike, and that's going to promote the uterine lining growth. So basically prepare the body every single month to become pregnant. And this is controlled by FSH and LH levels. And the secondary sex characteristics for female, you got like a higher pitched voice, you got more fat storage around the hips and things like that. The last one is progesterone, which is going to promote the uterine lining growth as well. And then when both those tank at the end of the month, they lose the uterine lining, and that's what a menstrual cycle basically is. Pineal gland, we have melatonin. Pineal gland is also in your brain. Melatonin is an interesting guy. The precursor to that, melatonin is vitamin D and a couple other chemicals. But melatonin is going to basically control your biological rhythms. Now, what's kind of interesting about melatonin in general, I think, is it's one of the only ones in your brain where your body doesn't say, hey, you're getting enough of it, let me bring it back down, or oh, you're not getting enough of it, let me bring it back up. Melatonin, you could be taking melatonin pills and your body will keep producing melatonin at the same rate. Your body could, for example, another one of these guys, like if I start taking testosterone, my body will stop producing testosterone because I'm getting enough through whatever I'm getting. And so therefore, if I stop taking the pills, there's going to be a lag time before my body starts making it again. That's kind of the general rule in the human body, is if you're going to give it something that it usually has to make, it's going to stop making it because it doesn't want to use up energy. Melatonin is the one that breaks this rule, to be honest with you. And it's one of the ones that it's kind of fascinating. Like you could take melatonin and not screw with how much you actually produce. Now you control your melatonin by the light and dark cycles. Melatonin is also a big component of a lot of acetylcholine and a couple other like brain chemicals that are used for learning and also for happiness and things like that. And so if you have a screwed up melatonin process because you're not following light dark cycles, you can get depressed very easily. It's one of the reasons why people that work second and third shift usually have higher rates of depression. It's because their melatonin is not being managed correctly. They're also not seeing the sun. I told you vitamin D was one of the precursors. You get vitamin D from seeing the sun. And then last but not least is thymus. Thymosin is fascinating right now. I think I brought this up in a different video, but I'm going to bring it up again. This stimulates your T cells, which is part of your immune system. T cells, their job is to fight things that you've never encountered before. Their job is to fight the guys that have never been in your body. So therefore, T cells are super important for the first time you get sick with something. After you get sick with something, you start producing antibodies. That way, if that thing comes back ever, your antibodies just connect to it and your immune system then attacks it. Now, why I bring this up is if I even maybe grab a paint, your T cell amount changes as you age. So your thymus actually maxes out. Let me grab a line here. Sorry. Wasn't planning on doing this. Your T cells actually max out when you're first born, and same with your thymus production, and it goes down as you age, and then it drops pretty quick, and then it goes basically to nothing at the end of your life. Because the idea here, I mean, mathematically, it makes sense. By the time I'm 80 years old, I've probably encountered everything I'm going to encounter. And you got to remember, humans weren't really evolved to live 80 years old. I mean, life expectancy has really increased over the last couple of years here. I mean, life expectancy about 300 years ago was about 40 to 35 years old. So we're talking about right here. Okay. So as we age, our T cells go down and our antibodies do the reverse, right? They go up because we've encountered more things. Now, why that's important right now is we have the coronavirus. And the coronavirus is brand new to everybody. And in small mammals, the coronavirus is nothing but a small cold. Like if a guinea pig gets a coronavirus, it will cough for about a week and then move on in its life. It's really not that bad of a virus per se to most things that are used to it. We're not used to it. And so we have no correlation or no antibodies that truly work that we think. We do have some research that says if you get if you've had other coronaviruses in the last couple of years, you do have a somewhat antibody immunity to it, but it's not perfect, but it does definitely bring down the level of sickness that you're going to get. So not that you should go right out and try to get coronavirus, but if you have had a cold the last couple of years, there is a small chance because coronavirus is not the only kind of colds out there. There's 20 different kind of cold types. 3 of them are coronavirus type viruses. You have a chance that it might not be as bad. But anyways, back to the thing. So people with a lot of T cells, the coronavirus is not a big deal. They're encountering it first time. They're like, oh, this ain't a big guy. This ain't a bad thing. But people that are really old, they don't have enough T cells. They only have antibodies as their defense, and they have no antibodies to defend. And so what their body does is it goes into nuclear mode, and that's where people are actually dying. The virus actually doesn't kill people. The virus causes your immune system to go ballistic, and the fact that it goes ballistic is what's causing all the problems mostly in people. When you hear the words like ARDS and things like that, that's what's happening. So young kids, that's why we don't see a lot of problems with them. Teenagers, 20s, 30s, and then you can basically follow this chart down and you can see the inverse. If I drew another line of the people that are dying of coronavirus, is basically the inverse of this T cell line. So it's quite fascinating. Just so you should know, thymus is in the middle of your chest. It starts out pretty big and it shrinks as you age and keeps getting smaller, smaller, and smaller. The interesting thing is because it's so active when you are young and not active when you're old, and especially when you get really old, we really don't know a ton about it. The not known part here is always surprising when you see it, but we're not going to chop into a little kid and screw up their thymus. And there's no cancer of the thymus because usually the thymus just kind of like I said, dwindles away. So there's not something where we get a lot of research on the thymus, and so it's not known. It's kind of interesting. So that's all the different hormones. Just a quick overview. If you have any questions on any of them, like I piqued your interest or you're intrigued or you want to know more, just let me know. I only went through them really, really quickly because I didn't want to take too much time. But I hope that was helpful, and I hope you guys will be ready for your quiz on Wednesday. Have a fantastic day.